Hello students and welcome back to this channel, and today we will discuss about this JEE paper, and this paper is of 1st February and first shift. Okay, 1st February first shift paper. As a whole the paper was quite easy, and like you should at least get 22 to 23 question correct at least. So in this paper I will discuss how to approach the question, how to do this question as early as possible, and I will not use any tricks and all these things. It's just basic chemistry. You have to know the chemistry, you have to give the answer, that's it. It's so easy and we will discuss one by one. Okay, so let's start. So the first question here is, which of the following is most likely attacked by electrophile? Which of the following is most likely to be attacked by electrophile? Okay, first of all we have to understand what is electrophile. Electrophile is denoted by E plus. Set this plus sign. Why this is a plus sign? Plus sign because it is electron deficient. So can I say that electrophile are electron deficient? Yes, definitely. And phile means loving. So electrophile means it loves electron. Now which of them, what is the product, like options given in between, you have to tell me which of them are electron rich. Sir, why do you need electron rich? Because if they wants to react with electrophile, as electrophile is electron deficient, so electrophile needs someone that can be electron rich, and then it will react again. So as electrophile is electron deficient, so if it is electron deficient, so electrophile is electron deficient, so you need someone that is electron rich, then only the reaction will proceed. Okay sir, I understand. That means I have to find which one of them is more electron rich. Yes, how to find? Okay, so we have to go to the next page. Let's see what is given. So sir, the second option was given as phenol. Second option is given as phenol, and phenol has lone pair of electron. It can do the resonance like this. As soon as it is doing the resonance like this, I hope I don't have to teach you how to do resonance. We are getting a negative charge. You are doing the resonance, you will get another negative charge. So in the ring there is negative charge. We can say there is negative charge is revolving in the ring. So can I say now that ring becomes, can I say the ring becomes electron rich? Yes, definitely I can say that the ring becomes electron rich. So it is satisfying the criteria to react with electron plus, E plus, because E plus is electron deficient and this is electron rich, so this will react. Okay sir, what is given? Sir, then it is given toluene. Sir, toluene also electron rich, right? Yes, toluene also electron rich, but this is by plus I effect only. This is by plus R effect. Are you getting my point? This is by plus R effect. Toluene is plus I effect, and we know that resonance is always predominating over inductive effect. So who is more electron rich? Sir, till whatever we have done till now, this is more electron rich. Okay, now there is a problem with chlorobenzene. Yes, chlorobenzene, what is happening? It is neatly deactivating, right? Overall deactivating. Why I have already discussed in the class, neatly deactivating, because for this minus I effect is predominating. That means it is actually withdrawing electron. From the ring, and ring is becoming electron deficient. Ring is deficient, said it will not react with E plus because E plus is also electron deficient. No, said no reaction. and in case of benzene there is no such effect, it is normal. So whatever we have done, we can write benzene is normal, no effect. Here it is plus R effect, here it is plus I effect, here predominantly it is minus I effect. This is more electron rich, this is more activating, this is more electron rich, and sir, phenol will be my answer. Option number 2 is my answer. So by this way you have to do this question. Okay, it's so easy. Okay, going to the next question. In the next question, Geldal method. Now in this purification and this estimation, there students may have some problem, but I have done this Geldal method, Carius method, Dumas method, all these method with all the numericals also. Okay, so what you have to do? Nothing. In Geldal method, what happened? Any nitrogen containing organic compound, okay, any nitrogen containing organic compound, this compound in the presence of CuSO4 as a catalyst, CuSO4 as a catalyst is transferred to ammonia gas, and this ammonia gas we used to estimate by P1 V1 by T1 equal to P2 V2 by T2 and all this. There then it is totally physical chemistry, some basic concepts of chemistry. That rule you have to apply here. It's very basic. So the main funda is nitrogen containing any organic compound, and from there we use CuSO4, and this CuSO4 is act as a catalyst. That means option number 3 will be my answer here, and we used to make it ammonia. If you want, I will make a detailed video about this, all this estimation process. Okay, because here I feel that some students are still having some problem. Okay, so here option number 3 will be your answer. Coming back to the next question, let's see what is given. pH3 will have low boiling point than NH3. No, that is not possible, because sir, they are talking about group 15, and group 15 I am having nitrogen, phosphorus, arsenic, antimony, bismuth. Sir, the first element this is capable of, like NH3, from here I will get NH3, from here I will get pH3. Sir, this ammonia is capable, or it is fulfilling the criteria to form hydrogen bonding. Sir, what is the criteria? The criteria is hydrogen should be directly attached to F or O or N, any one of them. Hydrogen should be attached with F or O or N, any one of them. This is the criteria. And this is fulfilling the criteria. It is hydrogens are attached with nitrogen. Okay, so as it can form hydrogen bonding, so obviously its boiling point will be more than the boiling point of pH3. So statement number 1 is not correct. There are strong van der Waals forces in NH3 and strong hydrogen bonding in pH3. No, in pH3 there is no hydrogen bonding. Hydrogen bonding is in NH3. So statement number 1 is also incorrect. Statement number 2 is also incorrect. So statement number 1 is saying statement number 1 is saying that pH3 will have low boiling point. Yes, pH3 will have low boiling point. So I am sorry, pardon me, statement 1 is correct and statement 2 is incorrect. That means the option will be option number 3 will be my correct answer. Okay, option number 3 will be my correct answer. Okay, moving to the next question. What is given? Which of the following has trigonal bipyramidal shape? Now this question, if I discuss this from beginning, then it will be like this. You have to calculate hybridization. Sir, how to calculate hybridization? So very quickly I just write the formula. I hope you know this. I have discussed this in detail twice in the class, like for the revision. H equal to half of number of valence shell electron of the central atom plus number of univalent atom minus charge of cation plus charge of anion. Okay, so this is the rule. Very easy. You see what I am doing here. H equal to half of number of valence shell electron of the central atom. Number of univalent atoms, and univalent atom means what you are saying. Suppose H plus is univalent, F minus univalent, Cl minus univalent, Br minus univalent, but O2 minus is not univalent. S2 minus is not univalent. Are you getting my point? I am not talking about positive or negative charge. No, positive negative charge doesn't matter. If it is univalent, it can be uni-positive, it can be uni-negative, no problem. I can take this type of things. Okay, so with this, you see what are the molecules given. One is PF5, one is PBr5, one is PCl5, one is FeCO whole 5, one is BrF5. These are the molecules. Okay, no problem, sir. We will do it very quickly. Okay, just let me give a moment to take. Yes. So, sir, what is given? PF5, PCl5, PBr5, then FeCO whole 5 and BrF5. In between this FeCO whole 5, you cannot do with this thing. Okay, so H equal to half of phosphorus. Phosphorus, what is the valence shell electron? You see number of valence shell electron of the central atom. Phosphorus valence shell electron is having 5. I hope you know. It is from group 15, and group 15 means 15 minus 10. That means 5 is the unpaired electron. Sorry, 5 is the valence shell electron. Plus, it is having fluoride. Fluoride is F minus. Sir, it is univalent. I can take. Yeah, no problem. So half into 10, that means 5. 5 means sp3d. That means that it is trigonal bipyramidal. Sorry, trigonal bipyramidal. Trigonal bipyramidal. Okay, sir, calculate for the other ones. It's so easy. You can also do H equal to half of same. All are same. 5 plus 5 equal to 5. sp3d. It is also trigonal bipyramidal. H equal to half of 5 plus 5 equal to 5. sp3d. It is having TBP geometry. Okay. Now here you see H equal to half of. Sir, bromine is the central atom. Bromine is from group 17. So 17 minus 10, that means 7 plus 5. That means that half into 12, that means 6. 6 means sp3d2. It is going to be a octahedral geometry. I am not going for shape till now. I am going for geometry. All of these are geometry. And FeCO whole 5. For that we have to do VBT, valence bond theory of coordination complex. That is, if you want, I can do. Okay, I'll do. Let me give a time for that. You see, FeCO whole 5, how to do? FeCO whole 5. First of all, CO is a neutral ligand. CO is a neutral ligand. As it is a neutral ligand, so Fe is in zero oxidation state. Okay. So Fe means what? Fe means 26. That means argon 4s2 3d6. 4s2 3d6. Sir, put it. Yes. So 1 2 3 4. This is 4s. This is 4p. This is 3d. Okay, let me just change the color. This is 3d. This is 4s. This is 4p. Sir, 3d 6. 1 2 3 4 5 6. Sir, 4s 2 electron, like that. This is okay. Now it is in zero oxidation state, no problem. Sir, now its CO is coming, and CO is a strong field ligand. CO is a strong field ligand. As it is a strong field ligand, then sir, what happens? Electron will get paired. Pairing up will take place. Pairing up will take place. That pairing up means what you are trying to say? I am trying to say is that 3D will be looking like this: 1, 2, 3, 4, 4s, 4p. This is 3D, this is 4s, this is 4p. What happens? These unpaired electrons will get paired up. Sir, why? Because CO is a strong field ligand. Strong field ligand is having the capability of pairing up the unpaired electron. Okay, sir, got it. Then they will get paired up like this. Yes, and these s electrons will also come like this. Okay, sir. Now what are the vacant orbital? You see, from vacant you are getting D, S and P3. So D, S, P3 hybridization, and DSP hybridization means it is again TBP geometry. It is again TBP geometry. So what they are asking? They are asking for trigonal bipyramidal geometry. Said this is PRF5, PBR5, PRF5, PBR5, PCL5, FCL5, all are TBP geometry. But this is also TBP shape also. For BRF5, okay, you see for BRF5 what happens? For BRF5, just yeah, here I have got octahedral, but octahedral is the not octahedral is the shape, octahedral is the geometry. Okay, sir, what is the shape? For that you have to understand what is the bond pair. Sir, how many bond pair? You see 5 fluorines are there, so 5 bond pair. Sir, how many lone pair? Sir, 6 is the hybridization, 5 is a bond pair, so 6 minus 5 is lone pair. Okay, sir, I understand. Now you try to do octahedral shape. You see, octahedral shape looks like this, but what I will do, I will put a lone pair here. Sir, why? Because you are having a lone pair. Now put the F's like this, put the F's like this, and if you see in your shape, always remember, in your shape lone pair is not counted. Lone pair is counted when you are doing for geometry. In your shape lone pair is not counted. Said it is looking like a square pyramidal structure. Very good. It is looking like a square pyramidal structure. Yes. So PRF5 will be having square pyramidal, and this is already done, this is already done, all are done. Yes. So TBP geometry I am getting from option number A. Option number A. As I have to do so many questions, I am doing it a little fast. Otherwise, I will do all the structures with you. SF6 if you do, it will be octahedral. BF3 if you do, it will be trigonal planar. And okay, that's it. PTCL4 you do, it will be square planar. Square planar, not pyramidal, square planar. Okay. If you want, I will do all that structure for you in a separate video. Okay. Now moving to the next question. What is the next question we are having? Yes, this is a very good question. It's an easy question. Adiabatic free expansion against vacuum. Sir, we know first law of thermodynamics. This is a very easy question. First law of thermodynamics. What is the first law of thermodynamics, sir? First law of thermodynamics is delta U equal to Q plus W. Very easy. Then, sir, what is the condition given? What are the conditions given? The first condition that is given is, I can say, free expansion. Free expansion. Sir, we know that you already told that free expansion W is equal to minus P external dV, right? And in free expansion, what happens? P external value is 0. So W equal to minus 0 into dV. That means that W becomes 0. Yes, in free expansion, what happens? W is 0. W is 0. Sir, what are the other condition that is given? Other condition that I can say is it's a adiabatic process. Sir, adiabatic process means there will be no heat change, right? Yes, there will be no heat change. in adiabatic process I can do this, and both the value if I put here Q as 0 because it's a adiabatic process, and I can put W value is equal to 0 because it is a free expansion, and if I put this I will get 0 plus 0 is equal to 0, delta U is also 0. So sir, that means I can say that option 1 is matching very beautifully, and that will be my answer. So easy, right? Okay, going to the next question. Yeah, this question is very easy, but they have given it in a different manner. So what they are asking, the following is the correct plot between lambda. Lambda is de Broglie wavelength and momentum. Sir, de Broglie wavelength means we have to write the equation, right? Yes, obviously you have to write the equation. De Broglie equation. Sir, what is de Broglie equation? De Broglie equation is lambda equal to h by p, where lambda is de Broglie wavelength, p is momentum, and what is h, said? H is called Planck's constant. Planck's constant. Okay. Okay, sir. So if this is the case, sir, can I say that lambda into p is equal to h? Yes, you can say. So can I say, sir, lambda into p is equal to a constant? Yes, you can say. Sir, if lambda is in y-axis, p is on x-axis, so can I say that xy equal to constant? And sir, xy equal to constant means the equation, the graph is always looking like a hyperbola. The graph always looking like a hyperbola, rectangular hyperbola. Okay, sir, we don't have to do anything here. We have already done these graphs in the class, and option number A will be my answer. Option number A will be my answer. So easy. Okay, then sir, go for this question. Sir, this is probably the easiest question, right? Yes, I also feel that this is very easy. Sir, Cr2O7 2 minus, in acidic medium I have to do the balancing. In acidic medium I have to do the balancing. So sir, it is already given 2 Cr3 plus. Okay, no problem. So both the side chromium is balanced. Both the side chromium is balanced. Sir, I can say that on the left hand side 7 oxygens are there, but sir, on the right hand side there is no oxygen. Sir, what I will do? Okay, no problem. Just add 7 H2O. Sir, I should, here on the left hand side I am having 7 oxygen extra. I should add oxygen. No, you cannot like add oxygen. You have to add water. Okay, sir. And sir, why 7? Because 7 oxygens are extra here, so you have to add 7 water, the same amount. Okay, sir, this is good. So because now I am having 7 oxygen on the right hand side also. But sir, there is another problem. Sir, hydrogen is not balanced. I am getting 14 hydrogen on the right hand side. No problem, as it is an acidic medium, you can add H plus. It is in your authority. There is no problem with that. Okay, sir, now everything is balanced. Yes, all the ions are balanced. Ions are all balanced. Now what I have to do? I have to balance electron. That's why it is called ion electron method, right? Ions are balanced. Now I have to balance electron. Yes, sir. So if you balance, you see how, what are the charge you are having here, sir? From here I can get the charge -2. From here, what is the charge you are getting? Sir, each hydrogen is +1. So 14 into +1, that means I am getting +14 as a charge. Okay, so what is the total charge you are getting? Sir, +12 I am getting as a total charge. What is the charge you are getting from here? Sir, each chromium is +3, so 2 chromium is in +6 charge. What is the charge you are getting? Sir, 0, because it is in neutral state. It is in neutral state. Okay, so total charge you are getting as +6. So +12 and +6, how to balance? You have to -6 here, right? And -6 means you have to add 6 electron here. You have to add 6 electron here. Now you write what is the equation that is given to you. The equation that is given to me is Cr2O7 plus XH plus Y electron minus 2 chromium 3 plus AH2O. And sir, by comparison I can say X value is 14. Sir, Y value is 6 and A value is 7. A value is 7. That I have to choose from here. X value 14, Y value 6, A value 7. That means that option number 2 is matching very beautifully. Option number 2 is matching very beautifully. That way you have to do this. Okay. Going to the next question. Sir, this is the easiest. Actually, the question paper is actually easy. Very easy, right? So DNA, what is the thing that, sir, you have already told that ATGC, this is the pairing. This is the complementary strand. ATGC. I have also told you how many hydrogen bonding and all this. Between A and T, there will be 2 hydrogen bonding, right? There will be 2 hydrogen bonding. All these things I have told you. Between G and C, there will be 3 hydrogen bonding. 3 hydrogen bonding. All these things you know. Okay. So, sir, A is complementary to T and G is complementary to C and vice versa. Okay, sir. Then this is given to me, right? Yes. A, T, G, C, T, T, C, A. It is given to me. Complementary I have to write. So, A complementary is T, T, A, G, C, C, G, T, A, T, A, G, C, A, T. So, T, A, C, G, T, A, C, G I am getting here, T, A, C, G and T, A, C, G and then A, G, T, G, T. That means that option number 2 is matching very beautifully. Option number 2 is matching very beautifully and that will be my answer. It's so easy. It's so easy. Okay. ATGC. Okay. Now going to the next question. Sir, this question can be a difficult one, but they have made it in a very easy way. What is the pH of CH3COO NH4 salt? So salt pH, if you have to do, so you have to use this formula. pH equal to, as it is from weak acid and weak base, as it is from weak acid and weak base. So the formula is pH equal to 7 minus half pKa minus pKb. I hope I have written it correctly. Yes, pH equal to half, so which is 7 minus half pKa minus pKb. Now the thing here is why the question is easy. You see, Ka value is given 1.8 into 10 to the power minus 6. So from here you have to do pK. Kb value is given also 1.8 into 10 to the power minus 6. So Ka and Kb both are equal. So that means pKa and pKb, that will also be equal. So pKa and pKb, if they are equal, then it will be 7 minus half into 0. I don't have to write anything. So the value will be 7. 7 will be my answer. Option A will be my answer. This question may be difficult if Ka and Kb value would be different. If Ka and Kb, if that was different, if they have given Ka and Kb different, then this question might be difficult. This question might be difficult. Are you getting my point? This question might be difficult, but as they have given both the value equal, so this will get cancelled out. So you are getting only 7 as your answer. Got it? Okay, now going to the next question. Okay, we are given with 3 NaCl sample and their Van 't Hoff factors. Okay, so NaCl is a strong electrolyte, right? NaCl is a strong electrolyte, and for strong electrolyte it is always 100% dissociated. Always 100% dissociated. That means its dissociation does not depend upon concentration. For whom it was depending upon, sir? For weak electrolyte. For weak electrolyte, you remember from class 11, there was Oswald dilution law, alpha proportional to 1 by root over C. For that, alpha, degree of dissociation, depends upon concentration. But as NaCl is a strong electrolyte, it is always 100% dissociated. And sir, always 100% dissociated means I value will be equal to N. N is the number of particle after dissociation. As it is, okay, sorry, as it is 100% dissociated, always it does not depend upon the concentration, it is always 100% dissociated. So I value is equal to N. I hope you know all of this, right? So number of particle after dissociation, N. Sir, what are you trying to say? I am trying to say NaCl, if you dissociate, you will get Na plus Cl minus, so total 2 particle. So for this also I value is I1 value is 2, for this also I2 value is 2, for I3 also I2 value is 2. So why this is the case? Because this value, this different concentration doesn't matter. All the time it is 100% dissociated. All the times it is 100% dissociated. All the time it is 100% dissociated. So sir, I1 equal to I2 equal to I3. That means option number A is my correct answer. Option number 1 is my correct answer. Got it? Okay. Now sir, this question, I love this question. This question might be a tricky one, but yes, you can do. Sir, toluene is given to me. Toluene is given to me CH3. That means it is toluene. Toluene is given to me, and it is given Cl2 2 equivalent. Said this 2 equivalent will be helpful, yes, and in presence of H nu. Sir, you told me, I know that H nu is whenever the reaction is in presence of H nu, that means it is free radical mechanism. That means the reaction is going through free radical mechanism. Sir, free radical mechanism means what are you trying to say? That means here what you will get, you will not get ring substitution, but you will get side chain substitution. These things, like whoever has taken the classes from me, several times I have done this question. Side chain substitution. Side chain substitution means that you are trying to say that I will get this as a product. Yes. 2 hydrogen from here will be substituted by 2 chlorine atoms. Sir, why 2 chlorine? Because it is given 2 equivalent. That's why. If it is given 1 equivalent, I will do 1 substitution. If it was given 3 equivalent, I will do 3 substitution. Okay, sir. Then, sir, it is given NaOH dilute HCl. So, sir, what is this? NaOH means OH minus. So, we can expect a substitution reaction here. We can expect a substitution reaction. Substitution reaction means that you are trying to say that benzene ring, with that you will get CH, OH, OH, right? Yes, both the Cl will be substituted by OH group. But now there is a problem. There is a problem. Sir, what problem, sir? What problem you are talking about? Yes, let me just take another page. Yes. So till now we have got this thing. CH, OH, OH we are getting. The same carbon is having 2 OH group, that is called JEM diol. Same carbon is having 2 OH group, that is called JEM diol, and I hope you know JEM diol are unstable. Sir, why unstable? Because the oxygen lone pair and all these things, repulsions are there. Okay, sir. So what will happen? This will give 1 water. This will release 1 water. Sir, which water? This H and this OH will leave. And if this is leaving, sir, I will get C double bond OH. That means benzaldehyde as the product. Benzaldehyde, that will be my B. Previously, this was my A. So, sir, which molecule is matching? This is option number C is matching very beautifully. Option number 3 is matching very beautifully. That will be your answer. Okay, that will be your answer. So as I am doing this question, so let's have a revision of this thing. Okay, let's have a revision of this thing. The revision is, suppose you are having, okay, hold on. Suppose you are having toluene. Suppose you are having toluene. You have done Cl2, you have done Cl2 1 equivalent in presence of H nu. You will get benzene ring with CH2Cl. Okay, you have done Cl2 2 equivalent H nu. You will get benzene ring with CHCl2. No problem. Then sir, you are doing Cl2 3 equivalent in presence of H nu. Then you will get CCCl3. No problem. Then you are doing hydrolysis. NaOH, HCl, all this reaction you are doing. If you are getting, then you are getting benzene ring with CH2OH. No problem, it is stable because chlorine is substituted by the OH group. Okay, same reaction if I am doing here, I'll get CH, OH, OH, said ZEM diol unstable. So ultimately I will get benzaldehyde. Ultimately I will get benzaldehyde. Okay, then same reaction I am doing here. Okay sir, I understand what you are trying to say. So I'll get COH, OH, OH, and this will leave. Ultimately I will get benzene ring with C double bond OOH. Please check it. I hope you will understand. This is benzyl alcohol, this is benzaldehyde, this is benzoic acid. Okay, so a quick revision of this thing I have done here. I hope you understand this thing. Okay, okay, going to the next question. This is an easy question. This is very easy actually, like it is quite easy. So mixture of a gas of 2 mole of a monoatomic gas, CVM value is given, and 6 mole of a diatomic gas, its CVM is given. Find the molar heat capacity of this. So what is the molar heat capacity? Nothing. So molar heat capacity will be, you see, CVM. I can write CVM. Okay, let me just do it a little. Yeah, so CVM I can write is, what is the number of mole? 2 mole. 2 mole into its CVM, that means 3R by 2 plus this is what, 6 mole and its CVR. I hope it is going behind my face, right? Okay, sorry. So yes, CVM equal to, I can write what, total CVM equal to, I can write that 2 mole is given, and for that 3R by 2, and 6 mole is given, and for that it is 5R by 2 and divided by, okay, total what is the mole, 2 plus 6, that means 8. Okay, so it will go cancel out, it will get cancel out. So 3R plus here, from here you are getting what, from here you are getting 3R, and from here you are getting 15R by 8, that means 18R by 8, that means it will be 9R by 4. So easy, option number A will be the answer. That's it. But some of you are still having, like, you are having doubt in this question, but there should not be any doubt. 2 mole into its molar heat capacity, 6 mole into its molar heat capacity, divided by the total number, then you will get the average, right? Then you will get the average, because you have to do for the mixture, you have to do for the mixture. So option number 1 will be your right answer here. Okay, okay. So now we'll go for the next question here. This question is like from haloalkane and haloaridine. Probably this question is discussed like the more number of time. That is said that Rx, that means alkyl halide, if it is given to you, alkyl halide, if it is given to you, if the reaction is by KCN, you will get RCN. If the reaction is by AgCN, it will be RNC. Several times this reaction is done with you, practiced with you, and with the proper explanation. If it is KCN, you will get alkyl cyanide. If it is RNC, it will be alkyl isocyanide. Alkyl isocyanide. So let's check the option. KCN reacts with Rx to give cyanide. Okay, cyanide, yes, cyanide you will get. And AgCN reacts with Rx to give isocyanide. Isocyanide, yes, so assertion is correct. Okay, then assertion is correct, then assertion is correct. Reason: KCN and AgCN both are ionic compound. No, KCN is ionic. KCN is ionic, but AgCN is covalent. AgCN is covalent. KCN is ionic. You will get K plus Cn minus like that. But AgCN is covalent. From Fajans rule, we can explain that. From Fajans rule, we can explain that AgCN is covalent. Okay, covalent. So if this is the case, then your assertion is correct, but reasons are false. Assertion is true, reason is false. Option number 3. That means that option number 3 will be my answer. Yes, got it. Then go for next. Okay, NiH2O, this is from coordination chapter. It's very easy question, right? NiH2O whole 6 2 plus is green color. Sir, NiH2O whole 6 2 plus, that means you see it is showing a color. You see green you cannot predict probably without the color wheel and all these things, right? But it is showing color. It is color. Why it is showing color? Because it must have from your book what is given. You see it is having unpaired, or we can say single d electron. That we have to establish if it is having or not. Okay sir, I can do H2O is neutral, so Ni is in +2 oxidation state. Ni is in +2 oxidation state. Sir, nickel, I know that nickel 28, it is argon 4s2 3d8. That means that nickel 2 plus, if I do, it will be argon 3d8, and set 3d8 I will write like this: 1 2 3 4 5 6 7 8, and said in presence of water. Water is a weak field ligand. Water is a weak field ligand. So sir, if it is a weak field ligand, no pairing, it will stay as it is. It will stay as it is. That means 1 2 3 4 like that, whatever it was present previously, now also the same thing. That means that 2 unpaired electron, as 2 unpaired electron, definitely and definitely it will be colored. Definitely and definitely it will be colored. Got it? Now NiCN whole for 2 minus is colorless. I know you know this, but it's my job, it's my duty to make you understand this thing. Okay sir, NiCN whole for 2 minus, how to do it sir? If it is colorless, then I have to prove that, if this is colorless, I have to prove that there is no unpaired electron. Okay sir, here it is x, just give me a moment, it is x plus 4 into Cn is -1 equal to -2, x minus 4 equal to -2, x equal to +2. Nickel is in +2 oxidation state. Nickel is in +2 oxidation state. Okay sir. Sir, what is normal nickel? Nickel is 28. All these things you know, 4s2 3d8. Sir, then nickel 2 plus, obviously here argon you are having, right? Nickel 2 plus is argon 3d8. That means sir, I can write it like this way: 1 2 3 4, and 4s also here, 4p also here. Yes, so 1 2 3 4 5 6 7 8 electron. But Cn minus is a strong field ligand. Cn minus is a strong field ligand, and as it is a strong field ligand, pairing will take place. Pairing up will take place. It will take place. And if this will take place, then what happens sir? Then 1 2 3 4, it will be like this. Then this orbital is vacant, this d orbital vacant, and from there this d orbital, this s, and this 2p, dsp2 hybridization, all this you know. But the problem here is no unpaired electron. No unpaired electron. Sir, as no unpaired electron, it is colorless. So both are true. Both the statement 1 is also true, true, and statement 2 is also true. That means that option number 2 is the correct answer here. Option number 2 is the correct answer here. Going to the next question. Okay, potassium hydrogen phthalate is a primary standard for NaOH solution. Yes, for NaOH, potassium hydrogen phthalate means what? Do you know phthalic acid? Phthalic acid. This is phthalic acid, right? This is phthalic acid. And potassium hydrogen phthalate means what? One of the hydrogen, not both the two. You see, it is two hydrogens that can show acidity, only one of them. So suppose like this, and it is intact. So this is called potassium hydrogen phthalate. Hydrogen phthalate. And this is indeed a primary standard for NaOH, because you see this hydrogen can be replaced by this sodium. Okay, so it is a primary standard for potassium hydrogen NaOH. And phenolphthalein is used to detect the complete of titration. That is we know. So both option 1 and 2 is correct. Option number A, like not A here, option number 1 is my correct answer here. Option number 1 is my correct answer here. Okay, then go to this. In aniline, what is the question? In aniline, NH2 group is strong deactivating group for all ESR. ESR means what? ESR means, what is ESR? ESR means aromatic electrophilic substitution reaction. Okay, ESR means electrophilic substitution reaction. Electrophilic substitution reaction. Okay, so let's check what is given. So aniline, but it is not given correctly, right? Aniline is nitrogen lone pair. It is doing the resonance like this. It is doing the resonance like this, and as soon as it is doing the resonance like this, you will get a negative charge here, then you will get a negative charge. That means ring is electron rich. Ring is electron rich. Ring is activated. Ring is activated. But here they are saying ring is deactivated. No, sir, statement 1 is not correct. Statement 2 is showing aniline does not show Friedel-Crafts reaction. That is true. Why? Why? Because aniline is looking like this. Can I say this nitrogen can donate the lone pair? Definitely. So aniline, this is a Lewis base. Sir, what is Lewis base? That donates electron. That donates electron. Okay. And if you remember, then in Friedel-Crafts reaction, we use AlCl3 as a catalyst. AlCl3 as a catalyst. This catalyst is a Lewis acid. This catalyst is a Lewis acid. Sir, why it is a Lewis acid? Because it accepts electron. It accepts electron. Okay, then sir, what happens? Just let me go to the next slide. Then sir, what happens? Aniline plus AlCl3, they will react. Aniline Lewis base donate electron, AlCl3 Lewis acid accepts electron, and they will make a acid base adduct like this. We can say that this is a Lewis acid base adduct. So what we are expecting is a Friedel-Crafts reaction, but no Friedel-Crafts reaction. They do this acid base reaction. That means Friedel-Crafts reaction is not possible. Friedel-Crafts reaction is not possible. That's why aniline does not participate in Friedel-Crafts reaction. Okay, so statement 1 is wrong, but statement 2 is very true. That means I guess option number 4 is your answer. Option number 4 is your answer. That statement 1 is incorrect, but statement 2 is correct. Got it? Okay. Going to the next question. which of the following is a homoleptic complex? This is probably the easiest. We have to understand homoleptic. What is homoleptic? When all the ligands, or we can say ligands, whatever you are pronouncing, that's correct, no problem. All the ligands are same, that is called homoleptic. Then sir, what is heteroleptic? Heteroleptic is when all the ligands are different. All the ligands are different. Okay, you see NiCN whole 4, all are Cn minus. All the ligands are Cn minus. Here, what are Cl? Two types of ligand. It is heteroleptic. It is heteroleptic. Okay. Cl2Br2, two types of ligand. Heteroleptic. NH3Cl, two types of ligand. Heteroleptic. Sir, which is homoleptic? Homoleptic is the first one, because four ligands, all are what do I say? All are same. So option number A will be, option number 1 will be your answer. Option number 1 will be your answer here. Okay. Then for ionic reaction in organic compound, which type of bond cleavage occurs? For ionic reaction, suppose you are having, suppose CH3C, CH3, CH3, Cl. For ionic reaction, you have to do this type of reaction, right? You have to do this type of cleavage. You have to get carbocation Cl minus. What type of bond cleavage is happening? And if both the electron has been taken by this is called heterolytic cleavage. This is called heterolytic cleavage. Heterolytic cleavage. Because if it was a homolytic cleavage, what happens? You will get free radical. Homolytic cleavage is like this. Homolytic cleavage is like this. So this is called homolytic cleavage. You will get free radical. Homolytic cleavage, free radical, all are same. Okay, no bond, that is not possible. Heterolytic cleavage will be your answer. Option number 1 will be your answer. These easy questions are given to like in the exam. Oh my god. Okay, so here what is given? Ka values of 3 acids are given. Okay, okay, Ka value A, B and C. Okay, then what are the values given? 10 to the power minus 3, 5 into 10 to the power minus 9 and 9 into 10 to the power minus 11. Okay, if this is given, then we can say the acidic strength. So easy. Acidity proportional to acidity proportional to Ka proportional to 1 by pKa, right? Acidity proportional to Ka proportional to 1 by pKa. So here Ka value is highest, as far as I can concern, minus 3, minus 9, minus 0. So this value is the highest, this value is the lowest. So this value is the lowest. So if I do Ka order, then A greater than B greater than C, and acidity order will also be the same. So acidity order will be A greater than B greater than C. That means what is your answer? Option number 1 will be your answer. Option number 1 will be your answer. Got it? Then go for the next thing, disproportionation. This is quite a good question, I can say, like disproportionation. Disproportionation meaning what? Disproportionation meaning, suppose you are having X in a compound and from there you are getting X plus X. Here X was suppose in plus 5 state. From plus 5 state it is going to plus 7 state and also going to suppose minus 2 state. So you see plus 5 to plus 7 when it is going, then I can say oxidation number increases. But when from +5 to -2 it is going, I can say oxidation number decreases. So for the same atom, please listen carefully, for the same atom, or we can say for the same species, same particle, if oxidation number increasing and oxidation number decreasing is happening simultaneously in the same reaction for the same element, that is called disproportionation reaction. Okay, let me go to the next page. Okay, we can do here also some of them. You see, first copper plus to copper 2 plus to copper. Okay, copper plus to copper 2 plus plus copper. So here copper is in zero oxidation state, right? Here copper is in zero oxidation state. So you see +1 to +2, increasing, and +1 to 0, that means decreasing. It is definitely a disproportionation reaction. Okay sir, understand. Now you do it for the next one. Yes, so MnO4 minus, MnO4 2 minus, I guess from here it is MnO4 minus plus MnO2. So we will discuss for manganese, right? We will discuss for manganese. So very quickly we will calculate the oxidation number. Manganese I will take X, 4, oxygen it will be -2, equal to overall it will be -2. So X minus 8 equal to -2, X equal to, I will get +6. So manganese is in +6 state. Manganese here I will take as X plus 4 into -2 is equal to -1. So X minus 8 equal to -1, X equal to +7. It is in +7 state. I will do for this manganese. Manganese I will take as X plus 2 into oxygen is -2 equal to 0. X minus 4 equal to 0. X equal to +4. So you see what is happening. Manganese was in +6 state. From here it is going to +7, increasing, and it is going to +4. That means decreasing. Definitely said this was also a disproportionation reaction. This was also a disproportionation reaction. Then H2O2, that part we have to do. Okay. So H2O2, from here it is getting O2 plus H2O, I guess. So H2O2 if I do for oxygen, we have to do definitely. So 2 hydrogen will be 2 into +1 plus oxygen I will take X. So 2X is equal to 0. So 2 plus 2X equal to 0, X equal to -1. Oxygen is in -1 state. Here obviously it is 0 state, and here it is +2 plus X equal to 0, X equal to -2 state. So you see -1 to 0, increasing, -1 to -2, decreasing. Definitely said this was also a disproportionation reaction. What is given? CrO4 2 minus to Cr3 plus. Okay, CrO4 2 minus, from here Cr3 plus. I think by seeing also we can say that this is not a disproportionation, right? Because you see here chromium is in X plus 4 into -2 equal to -2, X equal to +6 state. Here it is +3 state, so it is decreasing, but there is no chromium here, so I cannot say if it is increasing or decreasing. That is not a disproportionation reaction. Okay, so A is disproportionation, B is disproportionation, C is disproportionation. So matching is option number 4. Option number 4 is matching very beautifully, and that will be your answer. Okay. Find the total possible optical isomer of 2-chlorobutyl. Okay, so 2-chlorobutane should look like this. 1, 2, 3, 4 and 2-chlorobutane. If it is looking like this, then I can say I have to find chiral carbon. Sir, chiral carbon is, this is a chiral carbon because this is bonded with a methyl group, a ethyl group, a chlorine group, and obviously a hydrogen. All four are different. And all four are different means this is a chiral carbon. So how many chiral carbon you are having? How many? 1 chiral carbon. So how many stereoisomer? So number of possible stereoisomer, or we can say optical isomer formula is 2 to the power n, where n is the number of stereo center, or in this case we will say number of chiral center. So 2 to the power 1 equal to 2 will be the answer. And what are those? Those are, one is chlorine up, another one is chlorine down. So this 2 is the answer. Got it? So 2 will be your answer here. Very easy. Then go for the next question. This question, I like it. I like this question. So H plus plus H2, from here H2. Okay. It was given the E cell. E cell you have to calculate, and whenever you have to calculate E cell, you have to use Nernst equation, right? Whenever you have to calculate E cell, you have to use Nernst equation. But for E cell, we need E naught cell. Sir, E naught cell, for hydrogen electrode, E naught cell value is 0, as it is a standard state. Standard hydrogen electrode. Standard hydrogen electrode, its E naught cell value is 0. Okay, sir, calculate E equal to, according to Nernst equation, E equal to E naught cell minus 0.059, I am writing 0.06 by N log, we can say product by reactant. Okay, sir, if this is the case, then put the values. So E naught cell value is 0 minus 0.06 by number, N is number of electron changes, 2 log product is H2, but for H2 I have to take pressure P of H2, and reactant is H plus ion. It's having a stoichiometric coefficient 2 dot, that will be in the power. Okay, sir. Then this value is 0 minus 0.03. If I cancel it out, it will be 0.02 log pH2 value is given 2 atm, and this H plus value is given 1 molar square, that means 1, that means log 2. Then from here I want to go to the next page. So sir, E equal to, I got 0 minus 0.03 log 2. Now log 2 value you have to understand, in my class I have done a detailed discussion about the log table. Log 2 value is, we can say 0.3. Actually it is 0.301, but we can say 0.3. Okay, sir, if this is the case, then I can write 0, I don't have to write, so minus 0.03 into 0.3, that means that E value is coming as 0.009, right? 0.009. Okay, sir, then check, but they have given already the value is minus x into 10 to the power minus 3. Okay, so this value you have to write it in the form of minus x into 10 to the power minus 3. No problem, sir, I can write this as minus 9 into 10 to the power minus 3, and if I compare, I will get x value as 9. That will be your answer for this question. X value will be 9. That will be your answer for this question. Got it? So yes, here x value will be, find out x is 9. That will be your answer. Okay, then tell how number of deactivating group. Deactivating group means, we can say deactivating group means, I can write this as deactivating group means it is electron withdrawing group. Whoever will withdraw the electron from the benzene ring, that is electron withdrawing group. So what I will do, I will put all these groups with benzene ring. That means that you are talking about this thing. Yes, C triple bond N. So you see CN group is given there. I have taken this with a benzene ring, and this do this type of resonance. You see, it is withdrawing electron. From the benzene ring. Yes, sir, it is looking like this. And if this is the case, then you see it is electron withdrawing. I am not doing the other structures, because you already know these things. Okay, Then sir, NHCOCH3, what it will do? You see the atom that is directly bonded with benzene ring is nitrogen, that is having lone pair. That is having lone pair. So it will donate. It will donate towards the benzene ring. It will donate towards the benzene ring. So it will be like this. You see, benzene ring is becoming electron rich. You see, negative charge is revolving, right? Negative charge is revolving. Then what are the groups given? Said the next group that is given is benzene ring with C double bond O CH3. Again, it will do the resonance like this way. It will do the resonance like this way. Said if it is doing resonance like this way, then you will get this thing, right? Positive charge is moving, positive charge. Okay, then it is also electron withdrawing. And then what is given? NHCH3. Okay, NHCH3 is given. Benzene ring with NHCH3 is given. So what I will do, this is the resonance it will do. This is the resonance it will do. And as it will do this kind of resonance, you will get a negative charge here. That means, sir, I understand what you are saying, that this is electron withdrawing, this is electron donating, this is electron withdrawing, this is electron donating. Yes, got it? So by this way I can say that this is electron withdrawing and this is electron withdrawing, and they are deactivating. They are deactivating. So how many deactivating I am getting, sir? I am getting 2 deactivating. 2 will be your answer here. 2 will be your answer here. Got it? Then go for the next question. What is given? How many oxides are amphoteric in nature? Now this type of questions are not so good question, I would say, because you have to remember a lot of things. Okay, but we don't have anything to do, as it is in our syllabus we have to do. Okay, amphoteric means what? Amphoteric means, amphoteric oxide means it can show both the nature. It can show some acidic character, it can show some acidic character, it can show some basic character as well. It can show some basic character as well. Basic character means like reacting with, like after hydrolysis it will give a basic solution like that. So whoever is the answer, sir, SNO2 is the answer, PbO2 is the answer, and Al2O3 is the answer. These 3 are amphoteric oxide. These 3 are the amphoteric oxide. Amphoteric oxide. Sir, what about SiO2? You see, SiO2, silicon is in +4, that means highest oxidation state. P2O5, phosphorus is in +5, highest oxidation state. CO2, C is +4, it is in highest oxidation state. And in highest oxidation state, they show acidic character. They show acidic nature. They show acidic nature. Then sir, what about the others? You see, CO, NO, N2O, they are neutral. They are neutral. They are neutral. But these 3, which 3? SNO2, PbO2, and what do I say? Al2O3, they are amphoteric oxide. Okay, so 3 will be your answer here. 3 will be your answer here. Okay, going to the next question. For carbon dating of a wood sample, C14 by C, actually this is a very good question. If half-life of C4 is C1580, then I think you have to calculate T, right? Calculate T. This is the question. Calculate T. Okay, so this is actually a very good question. You see, this C14 by H12, C14 by C12, this is actually a ratio, right? This is a ratio. This is a ratio. Both the time you have taken the ratio. One time you have taken the ratio at T equal to 0. You see, T equal to 0. That means, can I say it is the initial concentration? Yes sir, you can say that this is the initial concentration. And C14 by C12, this ratio they have taken at T equal to T. That means this is at time T. Okay, now usually in a first order reaction, usually carbon dating and all this is for first order reaction. We used to say this is as A naught and this is as A. This is as A naught and this is A. So A naught, suppose it is A naught. Suppose it is A naught. You see how easily I can do this question. After 1 T half, what you will get? You are left with A naught by 2. After second T half, what will be the amount left? At this will be A naught by 4. And after another T half, you will get A naught by 8. And this is the thing you are having. You see, now you are having A naught by 8. That means there 1 T half, 2 T half, 3 T half, 3 half life, or we can say 3 T half is passed. 3 T half is passed. Then after you are getting this ratio as 1 by 8. Then sir, what is the time? Time is nothing but 3 into T half, 3 into 1580 04 47 4740 years will be the answer. 4740 years will be the answer. Years will be the answer. Got it or not? Very easily we can do this type of questions. Very easily. Okay. Now next question is what? What is the minimum energy required for an electron to excite from ground state to the first excited state of hydrogen atom? Very easy sir. Energy they are talking about E equal to, I can say H nu. E equal to H nu. Or we don't need this. We can do it very quickly, like E equal to, we can say minus 13.6 1 by minus 13.6 into Z square into 1 by N1 square minus 1 by N2 square. Sir, what is Z here? What is Z here? Z is the atomic number. Z is the atomic number. For hydrogen atom, so Z is equal to 1 for hydrogen atom. For hydrogen, atomic number is what? 1. Okay. Sir, what is N1? N1 always, it is the lower energy state. Lower energy state. Sir, what is N2? N2 is the higher energy state. N2 is the higher energy state. Okay, sir, I understand. Then what is given? So it will be minus 13.6, and this equation you can only use when you are doing this in electron volt unit. Okay, please listen carefully. This equation you can only use when you are doing it in electron volt unit. Minus 13.6 into 1 square, 1 by you see from ground state. Ground state means what? Lower energy state is 1 by 1 square. And fast excited state means, you see, this is your ground state and this is your fast excited state. It is n equal to 1, this is n equal to 2. So 2 square. So minus 13.6 into, it is 1 minus 1 by 4. That means minus 13.6 into 3 by 4. And the value will near about come around 4, and this it will be 25 and 9. 25 and 9 means 34, 3.4, and it will be minus 10.2. So yes, so the answer will be near about 10. Near about 10. Okay, 10 will be your answer. You have to give the answer in integer value. So 10 will be your answer. 10 electron volt. Okay. So by this way you have to do these questions. Okay. Then for the next question, find out moles of precipitate product. Okay, what is the precipitate product? They didn't mention. What is the precipitate product? They didn't mention. Oh, sorry. What is the precipitate product? They didn't mention. Okay, when 72 moles of PbCl2 and 50 moles of NaH4O2 is reacting. Okay. So this question is actually from limiting reagent, I guess. Let's see. PbCl2 and NaH4O2 SO4, if you react, then you will get PbSO4 plus 2NH4Cl, but this gets precipitated. PbSO4, this is gets precipitated, so this is your precipitate product. This is your, oh, now this becomes very easy, precipitate product. Why now it becomes very easy? You see, PbCl2, what is the given PbCl2 is given 72 mole, and NH4 whole to SO4 is given 50 mole. This is given. Okay, now yesterday only in the classes we have discussed this thing. So you see 1:1 relation, right? 1:1 relation. So if the reaction go with respect to PbCl2, then for 1 mole you need 1 mole. For 72 mole you need 72 mole. It is your need, but this is given. Okay, do you have enough? The answer is no. So the reaction cannot go with respect to PbCl2. Then you try for another one with respect to NH4 whole to SO4. NH4 whole to SO4. Now for 1 NH4 whole to SO4 you need 1 PbCl2. So for 50 you need 50. This is your need and this is given, and said I have enough, so the reaction can go by this way. NH4 whole to S, okay, I should not write it like here. NH4 whole to SO4 is your limiting reagent, Said if this is my limiting reagent, so 50 and 50 will react, and you see this is also 1, so 1:1 relation, so you will get 50 mole PbSO4. So 50 will be your answer here. 50 will be your answer. Got it? So by this way you have to do these questions. Any more question? No question. I have only got these questions. Okay, so we have done, you see, all the questions we have solved. Attacked by this one, then solved. Gel done. Hydrogen bonding done. Structure analysis done. Then thermodynamics done. de Broglie wavelength done. This is balancing in acidic medium done. Complementary DNA stand done. Then pH calculation of a weak acid, weak base salt done. Then Van 't Hoff factor from solution is done. Then this reaction from organic, it's a very good reaction, it is done. Then this is also from thermodynamics, this is done. This is from haloalkane haloarine chapter, that Rx with KCN will give RCN, with AgCN it will give RNC, done. And then yeah, this is from coordination complex, strong field, weak field ligand, and all this done. Then it is from again acid base ionic equilibrium chapter, done. Then aniline chemistry and Friedel-Crafts reaction, it is also done, that aniline does not participate in Friedel-Crafts. Nitrobenzene also does not participate in Friedel-Crafts, right? This is done. Then this is also homoleptic heteroleptic from coordination complex, done. This is a very easy question actually. I don't know why they have given this question. Heterolytic ligand from organic GOC chapter, it's done. Then acidity proportional to Ka proportional to 1 by pKa, from that you have given this question, it is done. Here I should write it like this way. pKa should be written like this way, right? pKa, here, done. Then disproportionate reaction from redox chapter is done, very good. Then possible isomer 2 to the power n formula, it is done. Then this is from electrochemistry, this is a very good question, it's done. Then activating group, deactivating group, it's good, done. Then these things you have to remember from this group analysis thing, okay? So it is also done. This is from kinetics chapter, a very easy question, but yeah, some of you may find it difficult, it's also done. And this is from structure of atom, electron transition, and all this done. Then this is from limiting reagents, some basic concept of chemistry. So done. So I hope you understand this, and if you have any problem, any question, if you are having any doubt, you can just like ask me in the comment box, or my Telegram or my WhatsApp number is already given to the description. you can directly contact me. Okay, so I hope you like this chapter, like in this session, and it will definitely help you, and you can send me the feedbacks for this also. Okay, thank you for watching. Bye.